Okay, please be quiet. Excuse me, I have to start. Excuse me. Thank you, John. All right. I think by now the new seating has fully sunk in. Are there any Unit 3 makeups left still? Like absent Friday, absent Monday, sub was not supposed to give it to you yesterday, Tuesday, so now it's Wednesday still doing the makeups. Anybody here know? I have a few reminders, things that you've probably heard already, but maybe you were absent on Monday, or maybe you zoned out. The assignment that should be labeled 4.4 is in your study guide labeled 4.5. That's a name problem. Where it says 4.5, that's actually 4.4. Then, please notice that they are out of order. Just a little confusion here, because the October schedule is always kind of dodgy. You should already have started a new warm-up sheet. I didn't remind you to do that on Monday, but by now it should be obvious because it's the third day of the unit. We could not show you Food Inc. last night because we don't have enough parents. We do have a parent for tonight, so it's on, 6 p.m. here. It's the same Food Inc. that some of you have already seen in your private lives or perhaps in a health class or something like that. And speaking of after-school films, we were all ready to do another awesome fishing movie on Tuesday and Wednesday next week, but someone pointed out that Tuesday of next week is Halloween, and so we'll probably be doing it just on Wednesday next week as well. You had a pre-lab due today. I'd like to remind you that there's a lot of confusion and the lab points really add up. In this unit, pre-lab, post-lab, post-lab, soil sample. 5 points of lab credit, which will double the lab credit that you have in your grade so far. Meaning that you could swing your grade by a full letter depending on how poorly or well you do on this unit. Please don't blow it. Right after Thanksgiving, wait, Halloween. Right after Halloween, you have a pre-lab, which is the longest pre-lab of the year, and you have to remind yourself to grab a single 2-cup sample of soil with no mulch or leaves or sticks from a place you know. Anybody want to ask me any questions about that? Go, bro.
Yesterday, did you guys finish the movie that you picked notes on with Meryl Streep, whatever it's called? Yeah.
Yesterday, the class was supposed to do that, I believe. And did they?
Yeah.
The sub said no big deal. There are 3 films in this unit. That was the first, and it's done. You can check it out for me if you need it. Speaking of which, that's the next thing I was going to talk about. Are there no questions about the soil lab? Then, speaking of yesterday, Sub told me it all went well. You only had a few questions, but general pattern, College Board likes to ask both sides of a debate. They're not giving you like a job interview for like Greenpeace or something. It's not like a whiny liberal or an environmentalism class. It's an environmental science class. So they'll ask you, like, what are the pros and cons of burning coal for electricity, of nuclear energy? And they kind of expect you to have some pros and some cons. Ecology, intro, doesn't have 2 sides to the topic. From now on, food, human population, energy, water, and so on, there's usually 2 separate sides. Food is a really good example. There's a perfectly good defensible reason to use genetically modified foods. There's a perfectly good defensible reason to use pesticide. There's a time when overhead sprinkler irrigation is totally reasonable. So, over the years, I've started to do something for students that they have told me was helpful, so I want you to know what that is. Number 27, where you have like sustainable traditional choices on one side and modern industrial commercial less sustainable on the other, you should keep that list going the whole unit. So mechanization causes erosion on the bad side. Contour plowing avoids erosion on the good side. Pesticides kill all the good bugs on the bad side. Pesticides can save an otherwise doomed crop on the good side. I know that that was written up there yesterday, but I'm not sure that everyone realized what I was shooting for. So I wanted to clarify now before we get too far away from yesterday's movie. Everyone successful? Good dog, man. You need some water. There's a good versus bad. You make 2 columns on a single sheet of paper. That's going to be number 27. Because the movie that started yesterday has a lot of good and bad stuff. And oh my God, in the movie yesterday, did you all notice the guy in the historical farm with the wacky tall hat?
Yeah.
What's up with that?
For the children.
I don't know why he had that hat. Yeah.
They dress up as pilgrims there and they like act like they're from the 1800s. I've been there.
No, I know, but what's up with that hat?
Like, well, who would need that? Why?
Well, because he rises, so when his head doesn't get too hot.
Like, what's the purpose of those hats? Wouldn't they just blow over? I really don't understand.
It's a legitimate 10-gallon vehicle.
Anyway, that was yesterday's movie. You'll be adding notes all of Unit 4, like it said yesterday. So leave lots of space, like it said yesterday, to that number 27 table where you compare good and bad. And by the end of the unit, if we have a few extra minutes, I'll help you organize yours like I have my list like that. Any feedback on my substitute yesterday? Anything I need to hear? We're going to do something similar on Friday. The sauna will no longer be as hot. Today should theoretically be the end of our heat wave, so by Friday it'll be only hot, not brutally hot. But I gotta be gone again. So there's like a rad movie. It's actually like really informative and more modern and easier to watch. About how aquaculture is much worse than we thought it was. How many of you have heard that the farmed salmon thing turned out to be a bad idea and most environmentalists recommend eating wild salmon now? In case you didn't know, that's a thing, and it turns out that farming seafood is actually, for the most part, a bust. This will explain why, and then we will talk about it later, but I gotta be gone that Friday. Okay. This is the same old warm-up you've seen before. We have a plan on the board. I've reminded you of your reminders. Are we all caught up? Are we back in school? Are we all caught up in school? Everything good? Are we ready to do this thing?
We're good.
Alright. You will need one sheet of lined paper in addition to the pre-lab you did. You could write on the back if you want, but you're writing too much.
Oh, you ripped out your pre-lab.
Blank sheet of paper.
I saw backside of pre-lab blank sheet of paper. Aiden being done ripping out 2 pieces of paper. You're gonna fuck it up. Guaranteed.
It's really good.
couple of years, the College Board asks you to design an experiment as part of one of the free response questions. It's usually just a part. So they would have a prompt about a topic, like how many kicks does it take to make Georgia cry? And then they would have some general questions about that topic, like tell me some stuff about kicking or tell me some stuff about Georgia crying. And then, usually like A or B or C, like a part of that question would be design an experiment that would help you determine how many kicks it takes to make Georgia cry. Every couple of years. And they did not ask an experimental design question last year. So the odds are good that they will ask your year. What's interesting is some kids come from like a really sciencey background where experimental design has already been happening a lot. But a lot of kids don't come from a sciencey background. So I'd like to give you, get ready for this, a 7-step process for how you think about your design for the experiment. And then we will bunch into groups and we'll talk about salinization and design an experiment, and you'll have a few minutes to start your experiment. Cool? For each of these 7 things, you're going to have like a brief little like step thing and then some notes to consider, I think. Are there any questions? That blank sheet of paper is the experimental design notes. Hey, this will also happen on one of my exams. I'm just not telling you which one. Number 1. Carefully phrase your question. For example, how does X affect Y? Or does X affect Y? Or is there a relationship between X and Y? Or what is the relationship? Where X and Y are your 2 variables, we'll come back to this. Number 2, if you're going to design an experiment, you should probably realize early on whether you are doing controlled or observational experiments. And it's easy to explain the controlled experiment as long as we explain the observed first. Does anybody know what an observational experiment is? An observed experiment? What's an observational experiment? Yeah?
You watch to see how long a caterpillar can crawl without being fired.
That's not even an experiment. That's just a measurement. Whose paper is this? I don't know. They didn't put their name on it. What's an observational experiment, really? That's also not an experiment. That's a measurement. You don't have to give me an example. You can just describe what makes it observational. That's kind of right. Yeah?
You get the experiment going, but you just have to see where it goes.
No. When you get it going, that's like every other experiment where you are going to watch it. But what do we not touch when we're doing an observational experiment? Look at your number 1. What kind of questions are you asking? That should be a hint for you. That's right. In an observational experiment, you don't manipulate the variables. You just find them. I will give you a long example that you may or may not want to write down, I don't know, but it should explain this difference. How does the concentration of selenium in the soil affect the number of species found growing there? An observational example would be randomly chosen block of dirt, measure selenium, count species. Randomly chosen chunk of dirt, measure selenium, count species. Randomly chosen chunk of dirt, measure the selenium, count the species. Randomly chosen chunk of dirt, measure the selenium, count the species. It's observational because I do not manipulate the selenium. I'm just hoping to find data with a range of selenium and a range of number of species found there. You see why it's observational? I just go find my data out in the field without having done anything to that field. What would be the controlled version of selenium and species? Yes?
Changing something in the soil and something like that.
Right, so, more specific to this experiment, I could create 10 different selenium concentrations in the ground, come back in 5 years and see how many species grow. Where I've manipulated the selenium concentration and then count the numbers. If you were going to ask me a question about this, you really should. Like, if you're kind of, like, I think maybe he'll say it later, I'm not going to say it later. Ask me now. Yeah?
I was going to say, doesn't like an observational experiment have like a lot of variables that you don't know about?
That is precisely correct. I'm glad you mentioned that. What if there's less species over here because there's another predator? Or there's more species over here because there also happens to be a buried horse in the ground that fertilized the dirt, right? So you can't rule out all those other variables. That's why it's an uncontrolled. You're not controlling all the other ones. But if you repeat this enough, for some types of data, that's as good as we can get. Usually observational data, you have to wonder what are the other variables. You're absolutely right. And that's a really good way to define a controlled experiment. It's where you manipulate one variable and leave all the other ones alone. That's why it's controlled, because you're controlling all the variables and then you're just adjusting one. You got both of these definitions. I know this feels boring. I'm just straight up lecturing to you and you're in the oven right now. But I gotta really make sure that we're clear because it's gonna come up later. Okay, you're making notes. I'm talking. That was number 1. That was number 2. Number 3. You should clearly know your variables. And a lot of times, kids say a word which they mean to be a variable, but they're not describing a variable. Just so you know, as a national average on experimental design questions, the biggest global weakness of high school students taking the AP Environmental Science exam on this type of question is that they don't adequately define variables. They'll say, is there something in the soil which affects Plant diversity. Well, the answer would be yes, probably, but that's not a variable. Or they would say, does soil which is better have more plant diversity? And the answer would be, well, kind of, but how do you measure betterness? So that's not a variable. So you write this down. For number 3, parentheses, identify, measure, separate, question mark. Identify slash, measure slash, separate, question mark. Identify, measure, separate, question mark. In other words, are these variables that you can identify, that you can measure, and that you can separate from other parts of the experiment? I know what you mean when you say better soil, but that's not the variable that you can identify, measure, or separate. So you could say nitrogen levels, that's something you can measure and separate from other variables. You could say phosphorus concentration. You could say percentage salt concentration, but it's got to be something you can identify, measure, separate. Okay. Do you remember this? This would be the right time to write it down again. Manipulated and responding variables, aka independent and dependent.
Hi, can you use Georgia for your book, please?
I don't know, it's kind of up to Georgia. If she wants to do school, she can do school. If she wants to do your book.
I'll do your book.
Hey.
Thank you.
Uh-huh. Next, number 4. Identify your control. And here comes the easiest definition so that you always get it straight. It is one without the manipulated variable. It lacks the variable you're messing with. The control is the sample, the data source. Without manipulation of the independent variable. We're almost done. 5, identify what you're going to measure. Remember, that's the other variable. That's the responding variable. And you got to be specific about how. So are we going to make a percentage, or are we going to count? Are we going to hold it up to a color card and find the closest matching color? Are we going to use a measuring tape or a scale or a stopwatch? Eyeballs? Number 6, describe how you will interpret the data. So if we see so-and-so, then we'll know so-and-so. Like, how are you going to interpret that? What do you expect to say? If we find that blah, 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 then we will know the blah, blah, blah. If we can figure out where the thing, or when the thing, or how much of this, then we could say that. So finally, you're ready for number 7, which is the last thing. Then you design your experiment. which is materials, layout, procedure outline, and data collection. I'll repeat. When you design an experiment for the AP test, you have to describe some materials, some layout, some outline of that experiment, and data collection. You do not need a step-by-step procedure on the AP test. You do not need a step-by-step procedure on the AP test. When they ask you to design an experiment, you don't need to say step number 1, gather all materials. Step number 2, return to your desk. Step number 3, wash your hands. You would say materials like using glassware, lab equipment, and a scale. Layout, like walk into the field and make squares that are 1 yard by 1 yard randomly. You don't have to describe exactly how you'll achieve perfect randomness. It's not step by step. It's giving an outline of the procedure. And there you have it. As long as you do that, you'll get a perfect score on every AP question that asks you to design an experiment. In case you're curious, about a week and a half before the AP test, I will give you every free response question they've asked in the last 21 years. And you can take all those questions and find all the ones that design an experiment, and if you use that 1 through 7, you're good. You're going to need that paper at least today, but you probably want to keep that around, because it's going to come up on one of my unit exams, maybe 2, and I won't tell you which one. Who'd like to ask me a question about how to design an experiment? Because otherwise I'm done. Yeah?
Do you have an handy acronym?
No. The only handy acronym I know in science is Hofbrinkel. Anyone else? Okay, it is officially 1,000 degrees. This is just not okay. I hate sweating at work. How many of you would rather be 1,000 degrees too cold than 1 degree too hot? Me too. You can always warm up. There's nothing you can do to cool off. Yeah, air conditioning. What the hell is air conditioning?
Oh, yeah.
Oh yeah, my iPad just pulled me down.
Yeah, and it also, plug it in doesn't trip.
That is a fair point. That was not freely dispersed.
Well, why can't we get a
specific.
grant for air conditioning?
I know. That's a good question. Don't ask Matt. We need to pick on Matt. Everybody always picks on Matt. Poor
Mr.
Matt.
Matt.
Yeah.
That's pretty funny. It's so funny.
The worst thing is, like, that is a reasonable conversation, and poor Matt, like, they have tried harder than any other academy I'm aware of to diversify their student population, and they've gotten closer than almost any academy in California. We're all just jealous because, like, parents should support all of school. Poor Matt. Okay, now me, different topic. Different topic. Raise your hand if you think you can find Israel on a map. Tight.
Somewhere over there. I've got it.
No, that's okay. That's
I've got
okay.
a pretty general area.
I mean, I should probably phrase this differently. Raise your hand if you can find Israel on a map and you are not Jewish. probably a few less things. Okay. The reason that I bring up Israel is because they have a really interesting problem, and I'd like to start from there. Israel has like really good soil for farming in many parts of Israel. Israel also has pretty limited water supply. They use a lot of groundwater. Groundwater tends to have a lot of dissolved minerals like Goleta. And if you've ever put tap water in a glass, especially in Goleta, like where I live now, you know the answer to the warm-up, which is repeated. You've seen this before by now. You should all know that when that mineral-rich tap water from Goleta evaporates, it leaves a ring of all those mineral deposits on the glass. Quiet, girls. I mentioned Israel because they have a whole lot of groundwater and they've got really good soil for farming. And they've got generally like nice weather for farming. Except with all that mineral-rich water, when they farm in a really hot, arid environment, aka the desert, all that water, instead of running off into the ocean, will usually evaporate in the field, leaving behind salt crystals. This is a process called salinization, where dirt gets saltier. On your lab paper, make sure that you know that's what we're talking about here. Salinization is making dirt saltier. Salinization is making dirt saltier because the water evaporates and the salts are left behind. This can get to be a big problem because if you accumulate too much salt, your dirt becomes like ocean salty when water is added. And most seeds don't grow in salt water. There was a period there when Israel kind of freaked out, and many farmers in Israel still struggle with this problem, that Israeli food production has really suffered because it's a really hot, arid landscape, and they have mineral-rich tap water, and a lot of their soils don't have steep drainage. So if you're making a farm in a basin, you add a bunch of water and it can't drain out, and it all evaporates, and you're just adding salt. And you repeat, you water 3 times a week for like 1,000 years, and you've basically built like an inland sea. You don't notice how inland seas happen? All the water evaporates, but the salts are left behind. Great Salt Lake, Mono Lake, Salton Sea, those are all inland oceans. That's why they're so salty. You don't notice why the ocean is salty? Because all the water goes in and can only evaporate, but it can't drain anywhere because it's already in the ocean, so the salts are left behind. So you wash all the minerals off the land and they all accumulate in the place where the water's already evaporated, aka the ocean. That's why the ocean is salty? How many of you just had your mind totally blown? Yeah.
I thought it was because some guy dropped salt in the ocean. That story.
His name is the baby Jesus, yes.
Does that mean that the ocean's slowly getting saltier?
Yes!
Was there a time where it wasn't salty?
Probably, presumably, I would suppose. I'm not an expert. But that is the logical conclusion, don't you think?
Yeah.
Yeah. Yeah, bro?
Would there be like a salt cycle, like would it go to the bottom and then?
There is. And so there's like critical concentrations where a lot of these minerals will crystallize even in water. Yeah. So there is kind of a salt cycle. It depends on temperature, pressure, and of course concentrations. There are some salts which fall out of solution at the bottom of the ocean. But I believe that the ocean is still well below the threshold for most salts. So if I'm not mistaken, every day the ocean becomes just a bazillion saltier. Yeah, bro?
I just have a question. How did the Dead Sea get so salty then?
Well, it probably gets a lot of input and no output. So you imagine that's all a question of concentration, like how much of that input is fresh versus how much of that input is sort of salty, right? So if you have like mineral deposits like salt flats, keep in mind that the Dead Sea is surrounded by desert, is it not? I don't know, the Middle East is all like, I don't know, over there somewhere. Is the Dead Sea in the Middle East? Ish?
Yeah, it's like on the border of Israel and Jordan.
Oh, tight, okay. Well, there you go. So surrounded by desert, which makes you assume that a lot of that water that falls as rainfall doesn't reach that sea. So I'm going to assume that there's already a lot of minerals accumulated in that soil. Plus, you add enough runoff every now and then to flush all that salt into a body of water that's also evaporating regularly, probably super saline. You guys want to hear a funny story? I went swimming in Mono Lake. All my blisters were all bubbling and boiling, and like my scabs were all hurting because it was so super salty. And I was just kind of like making myself take it because I've heard it's good for your injuries. I had spent my summers in the Sierra and like chopping wood and low humidity and climbing rocks. My hands get all tattered, my feet get all tattered. So somebody's like, oh bro, you should go take a dunk in Mono Lake, that'll heal you right up. And I was like, yeah, but I don't know, man, it's gonna hurt. They're like, yeah, it hurts a lot, but you gotta just give in and just do it. So I like swam out into Mono Lake, and I kind of like floated for a minute, treading water, and I was like, oh my God, yes, it's really painful. And I remember what my homie said, so I was just like, make myself tough it out. And I floated on my back, and I couldn't figure out what was different. I was like, this is weird, this is weird, this is really, really weird. Why is this so weird? And I thought it was the pain, and I was in like perfect like clinch mode, like every muscle in my body was all like, "Grr!" And I was like, make myself chill, make myself chill, make myself chill, make myself chill. I'm floating in Mono Lake. Thank you, Banana. I'm floating in Mono Lake. Leah just keeps them around so she can cover all her farts. She goes, oh, that's just the dog making noises. Sure, Leah, I know what you do. Floating in Mono Lake. I was like, why is it so weird? Why is it? And then I figured out why it's so weird. Mono Lake is so salty that you float higher. So my ears were out of the water. You know, when I go float in the ocean or in the lake, my ears are below the water. I float like this. But Mono Lake is so salty that the water density is so different that my ears were out of the water. And so I could hear the water splashing against the outside of my ears, and that's what I was not used to, and that's what was so weird. Neat, right? That's why inland seas get to be so salty. Water goes in, water can't leave. Do you notice the difference between a lake and a sea? Minds are being blown left and right. A lake is a sea with an outlet. Or a sea is a lake without an outlet. Anyway, back to me. Poor Israel. Groundwater, irrigate, hot and dry, no runoff, gets too salty. Brings up this question. I already know the answer, but let's pretend that I didn't know the answer. I wonder how much salt it takes to keep seeds from sprouting. Please take out your pre-lab. On that pre-lab, right, number 1, what question should we ask? What question should we ask about salt and sprouting seeds? This is not a rhetorical question. Yes?
What is the threshold salt concentration?
Okay, what is the threshold salt concentration beyond which seeds don't sprout? Okay, anybody think of another slightly different way to ask that same question? That would work for me, yeah?
At what salinity can seeds not grow?
At what salinity can seeds not grow? Okay. Anybody else? What about if you use one of those little formats that I gave you earlier for number 1? What? Use one of those formats I gave you for number 1. Yeah. Let's do that. How does salinity affect seed germination? That sounds nice. Number 2, what would an observational experiment look like? Come on. What would an observational experiment look like? Because our question was what now? What was our question? What is the relationship between salinity and germination?
How does salinity?
Okay, how does salinity affect germination? So what would be an observational example? How could I answer that just looking for information? Yeah,
Try to germinate seeds in different solutions of salt water.
that's a controlled experiment. We'll come back to that. What's an observational experiment? I gave you a lot of support for this. If your notes suck, you better fix your notes. Yeah.
Look at like different areas with different seed or like different plant populations and see how many grow compared to how salty the water is.
I suppose. Do you realize how cumbersome that would be? Trying to like count how many seeds are being dropped and then measuring how many of those germinate and fail to germinate. So let's do a controlled experiment. Number 3, what will be our 2 variables? What will be our 2 variables?
Salinization and seed growth.
What?
So, I think definitely wrong.
Salinization
Salinization and seed growth.
and seed growth. What do we call growing seeds? Does anybody know what that word is? Germination, yeah. And let's measure those as a percentage. Please look up. Percentage salinity and percentage germination. I hope you are all observing how we build an experiment, because this is the one time. Are these things which we can identify, measure, separate? Which one of these do we manipulate? Salinity is the one I manipulate. And I know some neat tricks that I will show you later about how we can make 0%, 10%, 20%, 30%, 40% salinity. So we can identify and measure and separate the salinity. Then, please look up, germination is easy. We'll say that if the root is anything smaller than the size of the seed, it's not germinated. And if the root is anything larger than the size of the seed, it is germinated. And we will use our eyeballs, and we'll be able to tell whether it's germinated or not. We've created a binary, yes germinated, no not germinated. So we can identify, measure, and separate that variable. We're good. Number 4, what would be a control group? No manipulation of that variable. What is no manipulation of that variable? 0% salt. That's just plain old tap water. Your lab thing says distilled water, but I mixed the salt water with tap, so 0% is tap. Hey, I'll give you a hint. Please look it up. The ocean is 3.5%. And I'll just tell you right now. I mean, the ocean's like 3.6 and a half. I'll just tell you right now, seeds don't germinate in salt water. So we got our variables, we got our control. Number 5, what are we going to measure? Come on, what are we going to measure? Yeah?
The length of the root on the seed.
No. That's how we will determine if the thing we measure is happening.
Germination.
What are we going to measure about germination?
Whether it's happening.
Actually, how much of it's happening. So look at me. If you put 10 seeds in each petri dish, isn't that convenient, you could make 100%, 90%, 80%, 70%, 60%, 50%, 40%, 30%, 20%, 10% germination. And that's what we're going to measure. How many of them germinated in each of the trays? So for number 6, here's what we're going to interpret. We're going to get some data points. And I don't know where, but somewhere, there will be this magic line, this tipping point in germination, where we could say, oh, this one is on her cell phone. We could also say there is like a decline in germination or a zero germination. There's your number 6. That's what we're probably going to see. Somewhere or other, we're going to find the salinity that affects germination. I just did something that for some of you is entirely foreign and for some of you is totally boring. For those of you that found this boring, I apologize. I'm taking students from all over our campus and trying to get them all to a 5 on this exam. So if you're bored, I apologize, but you just shut up and sit there for another couple minutes.
It's for ASB and the blood test. Can we talk to Keela for like a quick
Oh my god!
I'm so sorry, it's like super messy. And I'm trying to like have my life together. And like Rachel Rush is like screaming at me, so.
So you just come and trample on my life,
No,
which
I'm
I'm
not.
also trying to get together.
I know, I understand you're trying to like save the planet and stuff like that with like Apes, so I respect that. That's
I'm
like-
also sweating and trying not to like who would pass out because it's so hot.
Yeah, I get that. I'm really sorry. Thank you.
You don't look sorry at all. I know, he's like laughing. He doesn't look sorry. Looks like he's loving this. It's these days. Are we all clear on how I implemented 1 through 7 in this example about building up your salinization procedure? If you wanted to ask me, I'd love it if you asked me now, because I'm all yours. Then I'm just going to lay this out for you, and then you're going to do this lab. You're going to work in groups of 3. It'll be easy. You'll finish this up on time. Watch me, please. You will take a petri dish. And seeds usually sprout in dirt, but dirt has a lot of variables. You all realize that, right? So in a controlled experiment, where we want to simplify and have less variables, rather than use dirt, we're going to find a model for dirt. Like dirt, in terms of seed germination, is really just for the water. So how about we make little circles out of paper towel? You know, take a paper towel that is already folded into thirds, then fold that again into thirds. Then trace a petri dish onto it. Watch me. Once you've traced the petri dish onto it, take some scissors. It'll be difficult for you because you've got to stab yourself in the chest scissors. but cut out that circle. Throw all of your trash at Abby. And then check it out. Little paper circles. Okay, little paper circles. Aye, that hurt. You'll put 3 of those paper circles into the petri dish. Then you'll put exactly 10 seeds, and it's very important that you do 10 seeds. I'm not actually going to count these because I'm in a hurry, but you'll count them carefully. Put 10 seeds in there.
Oh my God.
Then we'll put 1 more layer of fake pretend dirt on top. Then we'll pour in 10 mils of solution. That will look like this. Watch me. You'll be very much exacting. Once you have your 10 mils of solution, you'll put a lid on top. Some of my knucklehead students in previous years have written on them. Please don't write on them. If they're already written on, you can ignore it, but please don't write on there. You'll label each one with your percentage salt water. You'll make a whole stack of those. You're going to have 6, right? Because you all wrote 6 in your thing, isn't that right? Should say 6 in there. And then watch me. 10 milliliters is on purpose so that you have too much. You have too much on purpose, because watch me. When you tilt that sideways, you'll create complementary angles so that they all fill to the same level. See what I'm saying? How they all fill to the same level?
Thanks.
And when they've all filled to the same level, you've controlled another variable. How much extra water is in there after you've soaked all the paper towels? Isn't this glorious? Then you take tape and you tape all the edges so the water can't evaporate. And then you tape it shut into a bundle and you write your name and period on it. Like this. Check it, check it, check it. I can't tip it over because these poor students would be bummed, but it has their names and periods on the top. There's a bundle of 6 different salinities. Are you just doing this to make more stuff to throw at me? Watch. You don't have to bother with 3.6 because we know that's the ocean and that's too high. You do have to have a 0, so you've got 5 salinities left. You can pick those, I don't care. If they're all slightly different, it gives us a more credible graph. So you could do 0.5, 1, 1.5, 2, 2.5 on top of your 0, that would be 6. Or you could break them evenly. You can decide, I don't care. And you know how your materials say 5% salt water? You can change that, it's actually 10%. Here's why it's 10%. Because I'm going to make 10 milliliters, and I'm going to use 10% salt water, get ready for this magic. Everyone needs to know this. I will only explain it once. Everyone needs to know this. Get ready, please. I will only explain it once. If you're trying to make 1.8% salinity, you use 1.8 milliliters of salt water, then top it off with fresh water up to 10 milliliters. And because it's 10%, 1.8 mils out of 10 mils is 1.8%. If I want to make 3%, I go to 3 milliliters with my salt water, and then I top it off to 10 with fresh water. However much salt water you use, however much salt water you use is your percentage solution if you top it up to 10 with fresh water. Touch your nose if you understood that. Oh, no way. Yes?
Wouldn't, if you put 3 milliliters of salt water, wouldn't that be 30%?
No, because you're already starting with 10%. It's not 100%. It's 30% of 10%. Watch. This is not straight rock salt. I'm giving you 10% NaCl, right? This is already 10%. Agreed?
Yeah.
If I'm going to go 3 out of 10, that's going to be 30%, right, of the starting. I'm not adding salt, right? 30% of 10% is 3. Because I'm obviously watering it down, it kind of makes sense that I'm going to get smaller than 10%. But if I'm adding fresh water, you're telling me it's going to become 30%? 30% of the starting solution. Make sense or no? Yeah? I think you're just lying. Anybody else want to ask me something? Yeah. Made me yawn. Yeah, you're working in groups. Anybody else? How did she not know that? Yes. Okay, fine.
Wait, that was okay.
Besides stacking all the things together, do you need to actually like record any data today?
Not yet. Nope. In about a week and a half, we'll record all that data.
Wait,
No, you can't.
that was the question.
So would we go much higher than 3.5%?
No, because 3.6 is ocean, and I'll guarantee it won't sprout in the ocean. What else? 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 Okay. I'm going to give you all your instructions, and then you're going to go. Here comes all your instructions. You'll bunch 1, 2, 3, 4, 5, 6. Gavin, your Cosmali today. Next. You'll take. Watch this. Watch this. One Sharpie, 1 roll of tape, 2 baby scissors, about 4 paper towels, 6 petri dishes top and bottom, 1 or 2 graduated cylinders, 1 or 2 pipetters. You'll take 1 bottle of fresh water. You'll take 1 bottle of salt water. Then look over here. You'll come by to collect seeds in 1 of your petri dishes. That's everything you need for the experiment. I'll let you know how much time you have left. Are there any questions? Are there any questions? Are there any questions? What? What?
We're only doing 1 petri dish?
That's not what I said. Just one of them gets a whole bunch of seeds. Ready, set, go!
Are you getting it all? I'm getting the dishes.
Hurry, 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 hurry! Hurry, 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 hurry! Hurry, hurry, hurry!
I found mine actually. I just thought I'd left it home.
If you're going too slow, help them. Move the desk. Do what you can. Go.
Oh, like nice.
We can stop the thing.